All right, let me go ahead and show you the different projects that I've set up here in BimlFlex. So what I want to do is I want to go and test with indating and without indating and run these through all of our different templates. So the templates that we have in BimlFlex that you can use is a couple of different ones. The first one is a ETL pattern, as I discussed, which is SSIS front to back. And the second one is obviously doing the same patterns, but doing that in SQL. And then the third one I'm going to show you here, which I've got configured over here at the top here, is actually the SQL-based pattern that copies the data to Polybase and then run the stored procedures or the SQL script. And the SQL script is the same pattern that we run for your normal SQL server, but it'll run that against Azure SQL Data Warehouse over here. Okay. So the first one I've got configured here is I've got two projects and I'll two connections set up here. And the one is going to be for SQL Server, and the one is going to be for SSIS. Okay, and it's set up this way. So effectively, I have got it set up here in the context where I'm going to run the one. Sorry, this is going to go be. So the differences in setting up in SSIS and BimlFlex to set it up for the difference between SSIS and SQL base is everything is the same. Your metadata is the same. The way you model, configure, everything is exactly the same. The only difference is instead of using an OLADB here going to SQL Server, I'm going to change this and say I'm going to use an OLADB based SQL based ETL, which then means that instead of using SSIS, it'll use stored procedures to do that. That's all I need to do. So then I've got that set up. I'm going to run, as you can see here, I'm running it all from AdventureWorks. Now I have made AdventureWorks a little larger. I think there's about 5 million rows in there, and I'm only going to grab one table. So the tables that I've got configured here and set up here is I have created a sales order detail table, which has 5 million rows, and I'm using it for both my SQL based and my SQL based end date, and I'm using it for my SSIS, and I'm also going to Polybase. So what you'll see here from my Azure SQL Data Warehouse is I want to read the data from AdventureWorks and put that into flat files. But I also want to use the multi-threading that comes with Polybase. So the way that I do that is I have gone ahead here and said that on this connection here, I want to have 16 threads. In other words, it's going to take that source query and split it across 16 files, so I can load 16 compressed zip files up to Polybase, which will give me the best multi-threading going on Polybase. The rest of the stuff is pretty simple. For every one of these sources, I have basically created a hub and a satellite, because I just want to compare the ETL load speeds when I'm loading into these different environments with indating and without indating, because the whole thing is here: should you indate or should you not indate? And one of the main consideration when indating is that it's for performance, because you want to do insert only to make your ETL load as quick as possible. So I will go and show you the differences and how much longer it takes when you do indating. I'm not going to cover off using point-in-time tables in this session. Point-in-time tables will be in a separate video. If you're not doing indating, getting the data out of the satellites, you definitely will have to implement point-in-time tables, in my opinion, because otherwise your data mart queries are not going to perform as well as they could. So to enable indating, in BimlFlex we have a lot of settings here. As you can see, there is a number of settings here that you can set. Almost everything is configurable. Actual fact is we haven't really found anything that's not configurable. To sort of decide to indate or not to indate. So the default setting of enable indate RDV for raw data vault is set to no. In other words, our default behavior is that we don't indate, and we obviously don't recommend to indate. However, you may be in a position where you want to indate a satellite for whatever the reasons are to you, or your standard may be to indate your satellites. Then you just switch this to yes. However, let's just say that we want nothing indated except for one satellite or one hub, and whatever that one is. So what you can do is you can go ahead and actually indate that. So if we look at our objects again, as I said, we have a project here. So this project here, the source 2. source 1 will be no end dating, and I want these two tables to go to an end dated table here. So I need to look at my satellites here. So obviously this is one here that has an end date. I want this satellite to be end dated, and I want this satellite to be end dated. And obviously the Azure one, I'm just going to leave it as is. So all I need to do here is grab this and go ahead to my attribute. So I've prepared this already for you. In other words, what I've done here is I've set up the attribute key setting value. In other words, what I'm saying there is that I want to change this setting value, and I want to override this enable end date for a very specific section. So I say I want to go and override the enable end date to yes for the first SQL connection. Here is the SQL int one, and I want to pick this table here, this satellite here, and say that this is the satellite that I want to end date. The other satellite I don't want to end date. And if I go to the SSIS one here, or the that one, nope, that's the wrong one. This one here, and I now pick that end dating satellite. I'm now saying that for these two satellites, actually I want to end date them. So I'm going to go ahead here and go and set current sheet. And let me head over to Biml Studio now, and now I will refresh my metadata. And after I've refreshed my meta, I will go and build out all the code. All right, so I have built out all my code, and let me go and show you just the high level differences between the two things. So first I'm going to look at the SSIS packages, and we will have two SSIS packages. And the first one here will be, we'll do the normal load, and I'm not going to go into the details of these data flows, but this data flow here, as you can see, it's got no end process that will actually go and do end dating. The second data flow will actually do exactly the same things, but it has this additional update statement that will end date your satellites for you. Now this is the same whether you're using link satellites or any other satellite type will do the end dating for you. So now I've got my two packages that will run. I'm going to deploy this to my SQL server, and we'll execute those there to see how they perform. And then also what I have generated out is the stored procedures. Now what you'll see here is the first one here that doesn't do end dating, and at the end of the stored procedure, as you can see, there's quite a bit of code there. There's no end dating script there. And the second one is the same. However, at the what it does have at the end is it actually has this logic here that will do the end dating. Okay, so that's the differences in deuces. The one will end date, the one will not end date. Okay, that's basically the bottom line of it. So I'm going to go ahead and deploy all of these packages, then I'm going to execute it. So what I have done to date already is I've already gone ahead and run this source staging. So I've got all of these tables here, and if I just look at this, I've got they effectively already have their data in. So they all have about close on 5 million rows there, and I'm just going to go and run those different ones so that I can go and show you the performance of both the SSIS and the SQL Server with end dating and without end dating. All right, so all the code has been deployed, and what I'm going to go ahead right now is run these batches. I just want to point out when I run these batches that I'm trying to do this as to compare like for like as best I can, but bearing in mind that this is not sort of like a lab where everything is set up perfectly. This is just my laptop here running the code, but I think you will get an indication of the different approaches that we use and how you may want to choose different options for different things. So let me first go ahead here and execute the first batch here, and just execute it, and I'm going to execute the second batch. Then I'm going to show you the results of those, or the performance results. Then I'll go and execute the stored procedures, and again we'll look at how they perform, how fast they run, how quick they run, and then put those side by side. And then what I'll also then do is run an update statement and then go through the same process again. And I'll go execute there. So I'm going to run both batches now and then come back and show you the performance. Okay, so after the first run, I've got the results back here, and actually I'm going to have to run this again a couple more times just to get a real good time, because I'm not sure if, again, as I said, this is not lab conditions, so there might have been processes running on my laptop here. But what you can see here is that it took about 7 minutes for the SSIS to run, and for the end dating it only takes 6 minutes 30. So I would have probably thought those results were the other way around. So I'm going to go ahead and run this 2 or 3 more times just to get a baseline and make sure that there's no sort of CPU processing issues that gone in here. and just get an average of those runs. Okay, so I've just run these packages a number more times, and as you can see here, the results are pretty consistent. And the reason for that is that because on our initial load, the indating is actually calculated in flight. In other words, in the SI's package, it's calculated in flight, so there is no real indating to be run. And that's why this is the same. So what I've also done in Biml catalog, so we use the Biml catalog to track all of the history and executions. But you can go into the Biml catalog, and in the admin configuration settings, if you just go and edit the top 200, there is one setting here called log task execution. In other words, by default, we just log the package execution because 99% of the time you just want to see how long it took for the package to run. But every now and again you want to go and investigate the different tasks in the package, so you can switch this on to yes here. Now Biml catalog is obviously also open source. You can go onto GitHub and go Verigens Biml catalog. We've open sourced the logging engine there. We've also had one of our partners build a dashboard. So our partner BitQ has actually put a really good Power BI dashboard over the top of the Biml catalog that again you can download and have a look at. But yeah, so that's the reason why we didn't really see any differences here. You can see they're very consistent here because there is actually no indating on the initial load, because the initial load, the indating is calculated in flight in the SI's packages. So I'm going to go ahead and run the SQL code now and show you the differences here. So as you can see here, it's sort of 6 minutes 20-ish, right? So we'll say that that's the baseline. Takes about 6 minutes 20 for this SI's package just to run the initial load when it comes to a satellite. So I'm going to go ahead and run the stored procedures, and then we're going to run some changes and run the next version. Alright, so the stored procedures have now executed, and the first one without the indating has run in 2 minutes 56, as you can see here, and then the one with the indating is running 2 minutes 44. Now, I'd like to point out again, on the initial load, when there's no data, the indating is actually done in flight when we do the row condensing. Now, row condensing is the ABA scenario in satellites where you have a change, and then you have another change, and then you have a change back to the next. So in the logic where we actually calculate those ABA changes so that we only get all the condensed changes coming through. So you could actually have, especially if you're CDC and you've split your satellites, you could have 50 changes in a batch. You could have 50 changes to one business key, but as you've split your satellite, there may only be 3 real changes for that set of columns, right? So in that ABA logic, because we are doing that condensing, we are also doing the indating using the lag functions there, the lead and the lag function there. So therefore, these two values are quite close to each other. I don't think there's any differences. And in actual fact, in the initial load, they actually perform exactly the same operation. So what I'm going to do now is I have prepared a query here. Oops, not there. Over here, which is just basically going to go into that AdventureWorks LT Big and go and grab probably about 600,000. Grab about 420,000 rows there, and it's going to go and update them and just set the modified date. I'm now going to go and extract those 420,000 changes and push that through to the Delta load. Now, obviously it's not 5 million changes, so it's 420,000 rows coming through, and now we can probably go and have a look at the indating, because this is where the indating logic coming in, and we can then see the impact of those changes. Let's go have a look. All right, so I've actually gone ahead and made some more changes. I've actually now got about 1.3 million rows in there, and if I look at my staging environment here, over here, and I just look at how many rows I have to process. So I'm going to simulate about 1.3 rows of changes into all of these packages, and this is where we should now see the real difference between code with the indating and code without the indating. Now, before I run this, I personally don't think there is a massive difference in the performance, But let's see what the results go. And let's run these packages and see what happens. All right, so here's the results, and this is probably a good indication of how you could have an opinion about something, and then when you start running some analysis, you actually realize that you are not as that your thoughts are, or the way that you thought about it is not correct. So what we're going to do here is the one without the indating is 37 seconds, the one with the indating is 1 minute 4. So what I'm going to do, go ahead now, is actually run the stored procedure. So I'm going to just run the one without the indating here. And then I'm going to run the one with the indating also. I'm not expecting this to take a whole lot of time, so I might as well just wait for this to complete here. Now the differences between obviously running SQL code and running SSIS code is that with SQL code, you don't have that deep level of logging and auditing that you get with SSIS, you know. So that's another thing that you may look into is how much auditing and logging is happening there. Okay. So let me run these packages and I'll get back to you with the results. Okay, so I've actually now run the stored procedures, the one with the indating and one without the indating, and the one without the indating takes 39 seconds, as you can see here, and the one with the indating takes 40 seconds, as you can see here. Now, as I said, for me personally, there's no significant difference in the ELT portion of it. Obviously in the SSIS portion of it, it seemed to be a lot more difference. So I actually did some additional analysis on the SQL Server database, the catalog, and here's the query I ran. So what you can see here is that actually there was quite a large duration on running the indating update statement. It doesn't appear to be as big make as big a difference when we are running this sort of stored procedure code. And that's just because the code obviously in the ELT is a little bit more optimized for that kind of stuff. So I have also gone ahead and run this on Azure Blob Storage, and the results there is also quite interesting. And I'm going to pull it up here. I've got it here somewhere. Here we go. So on Azure SQL Data Warehouse, here are the results, and I'm going to put this all together in a little bit here. I'll just bring it across here so you can see that over here going on. So what the initial load is actually quite interesting. When I was running an Azure SQL Data Warehouse with 100 data warehouse units, running the same stored procedure code here, and I just ran the with the indating one. I didn't go ahead and split that out. It took 3 minutes and 3 seconds, and I ran that 2 or 3 times. It was roughly in the 3-minute region. However, when I upped the SQL Data Warehouse using the 400, it only took a minute. And that's because of obviously the poly-based parallelism that you get when you go up with data warehouse units. Now, Azure SQL Data Warehouse, we've been using it for a while with a lot of our customers, and it seems to behave or give you optimal performance when you actually have more data to load. So it's kind of one of those things that with small sample data sets, you don't really get to see the benefits of running something that's with the MPP system. So you really need to, if you want to run these tests, you want to go big. Now, let me wrap all of this up into a single slide and show you all the results, and then I will kind of summarize what I think about all of this sort of indating, not indating situation. All right, I've actually gone ahead and run the delta loads again, and there was a difference in the indating in the SQL set and the satellites. So I ran that a couple more times just to verify, and I will share the results with you. Before we look at the result, or as we look at the results, I just want to make sure that I point out here, be very careful to jump to conclusions here in the context of, oh, well, this one is faster, so therefore I need to do this. What I'm trying to show you here is that with BimlFlex, you have options to choose the path that is right for you. Now, that path may be an SSIS path, it may be a SQL path. Your environment may be configured differently, where SSIS performs better than SQL Server because you have different server configurations. I think having those options available to you is vitally important, and that's what BimlFlex brings to you. So let's have a look at the ETL with indating. So this is the SSIS packages. Now, between these two, the initial load actually runs the same execution path, and therefore there's no differences at the execution of the initial load. When we applied the delta, of about 1.3 million rows, we see that without the indating takes only about 40 seconds. And then with indating, it takes a minute and 5 seconds. So that's about 40% less performant. So you will gain over time, as I said, with the indating. It does have a performance impact. I'm actually quite surprised about this number here, but I ran these ETLs a number of times, and it is roughly around that. It could, and sometimes it's lower, it's 20%, but it does depend. And these results may vary on your system. Then we get into the SQL Server space, and again, the initial load takes the same path, and it's roughly about two minutes, 2 minutes 50. It varies there between 2.5 minutes and 3 minutes. I've run this about 4 times now, and that's roughly what it takes. Then I actually ran the delta load through this a couple of times, and it's quite interesting that you'll see this, and this is quite interesting where we look at the delta loads from a ETL or ELT point of view. Now again, this may vary, but it was it was quite similar to the SSIS, right, of 40 seconds here, because it needs to do a fair amount of work, right? And then again, the indating part of it was the same. So there was a similar increase here because the SQL query that we ran at the end of our exercise is the same as the SQL query that we ran over here to do the indating. So you would assume that amount is same. But what was interesting for me when I ran this was that the SQL portion of it, the ETL or ELT portion of it, was a lot faster on the initial load because it's not taking all of that data out and bringing it back in. But on the delta loads, they performed very close to the same. So that's what I'm saying is that you may be tempted to just go down one path, but you need to understand that with SSIS you get a lot more telemetry, you get a lot more flexibility that you can use. But with SQL-based ELT, there is, in certain circumstances, there are performance gains to be had. So what you need to do, take in consideration, is that you can split your ETL and or your data integration and data automation. You can actually split this up into having some of your packages run on SSIS and some of them running on SQL. The key thing to do with BimlFlex is that the way that you configure your metadata is the same, and then you just choose your build option. What we've done since then is I've run some more tests on Azure SQL Data Warehouse, and that just blows all of these things out of the water when it comes to really large volumes of data. So we've run a test on about 50 million rows, and there's about a 60% performance improvement on average if you go to Azure SQL Data Warehouse. So if you've got large data sets, and what I mean by large data sets, we're talking about terabyte data sets. BimlFlex absolutely can handle that because we can also build the ELT for Azure SQL Data Warehouse. I thank you for watching, and I hope that it was informative for you, and I hope to see you at the next session. Bye.